Hello, my name's Dr. Maggie Aderin-Pocock, and I'd just like to say it's a wonderful honour to be here today. A few apologies, first of all. I love STEM, and when I talk about STEM, I get very excited. And when I get excited, I speak very quickly. Not a good idea in this audience. So if I do speak too quickly, please wave at me and I'll try and slow down. So I want you to start with my first slide, please. And I want to make a provocative statement. My name is Dr. Maggie Aderin-Pocock, and I know nothing about art, literature, or history. Now, I'm just going to let that sink in for a second. Because even saying those words, I feel quite embarrassed. Because when I say that, I feel ignorant, I feel uncultured, I feel quite stupid, really. And yet, at the same time, if I came up here and said, my name's Dr. Maggie Aderin-Pocock, and I know nothing about STEM, many people in the audience will probably be agreeing with me. Yes, I don't know anything about STEM either. And they'll be quite proud of the fact that they know nothing about STEM. So why is this? Why do we have this dichotomy? Now, I think this is especially strange, considering the environment we live in today. STEM is of great importance. I've got a graph here showing the predicted spend on R&D in a number of countries across the world. This report was taken by the Royal Society in London, and it shows the predicted STEM across the world. And as you can see, across the board, with all these countries, research and development investment is going up. People think STEM is important. In the UK, we call it the knowledge economy. We're not manufacturing so much anymore, so it's important that we do other things. We need the entrepreneurs, the innovators, and STEM produces those. So why are we proud of not understanding STEM? Let's look at economy now. The human genome was a project that completed about 10 years ago, and much money was invested in investigating the human genome, understanding our DNA, understanding what really makes us us. And yet, in the 10 years since then, if you look at a sort of input-output analysis, it seems that for every $1 that was put into the Genome Project, $141 has returned. We have got $141 for every $1 we put in. So STEM is a money manufacturer. It is a powerhouse for economies. And many countries across the world are relying on that, and they want STEM practitioners to power this powerhouse. At this stage, I think I really should declare a bias, because to me, STEM has effectively saved me. I have been saved by STEM. And I say this because a number of years ago, I was a black dyslexic kid growing up in London, first generation, and I was sitting at the back of the class in school. I was in the remedial class with the safety scissors and the glitter, not really doing very much at school at all. But although I suffer from dyslexia, so my reading and writing is atrocious, you may spot some spelling mistakes. At the same time, I have an aptitude for STEM. I'm quite logical. And I remember the first time I was sitting in a class and we were doing science, and a teacher asked a question and I put up my hand. And then I looked around the class and I put my hand down again because no one else had their hand up. And I thought, hold it, I'm the dumb one. How can I know the answer? But I tried again and I answered the question and I got it right. And I think at that stage, my life was transformed. Because suddenly I thought, this is a subject that I know and understand. But it's more than that. This was a subject that was hoping to help me fulfill my dream. From a child of 3, I dreamed of going into space. And it seemed like a very distant dream. I remember one day telling a teacher, when I grow up, I want to be an astronaut. And the teacher said, oh dear, Maggie, you're not very good in school. Why don't you be a nurse instead? Now, nursing is a wonderful profession, but my dream was to be an astronaut. But it seemed like a very far away dream. But at the same time, I knew it was the STEM people who put people in space. So through my use of STEM, I suddenly started doing a lot better at school. And I went on to do a degree in physics at Imperial College, and then stay on and do a PhD there. And now I've been practicing STEM for about 23 years, and I'm a space scientist. It still surprises me when I say it, but I'm a space scientist, and I love the work I do. But of the order of 7 years ago, I realized that I'm a rocket scientist. I love the work I do. I travel the world, and I can make a real difference to people's lives. And yet I was trying to recruit other space scientists to take over the work, and I couldn't recruit anyone. So at that stage, I decided that I needed to go out and speak to people and spread the word and tell them how powerful STEM is, how it influences all our lives, and how it needs to be celebrated. So that's what I want to do in the next few slides. First of all, I want to start with the fairly mundane. I want to look at STEM and the media, because I argue that everybody needs an awareness of STEM to just operate in everyday life. I want to give you a few examples of why that is necessary. So I want to talk about advertising, I want to talk about reporting, on the news, in newspapers, and I also want to talk about the scientific method. So advertising. I want to tell you about a new miracle wonder cure called the Dr. Maggie supplement. Now, this is our patient before. You can see she looks down, lackluster, very sad. But with one application of Maggie's new wonder drug, she is transformed into a vibrant, happy person. And so this was just one application. And 75% of the users said that with just one application, they could see a visible difference. Now, there are a number of things wrong with this advert. That's a very, very bad picture of me to start with, but we'll leave that. But advertising is a powerful tool, but it can be used and it can be manipulated. I don't blame the media for this. People want to sell products, but we need the ability to see past the smokescreen. So if you look at the two pictures, they are very different in perspective. One is sort of with a rather dowdy background, the other one is a light, bright background. The way the photographs are taken are quite emotive. And if you look, 75% of women, but my sample rate is only 4 women. We need the ability to be able to see past these tricks so we know what's really going on. It's a bit of a funny example, but it's an example. So, reporting in the media. Media reporting of science, I think, has got improved vastly over the years, but there are still some challenges to be had. Recently in the UK, there have been a number of controversies, and one was the MMR vaccine, the mumps, measles and rubella vaccine. And this was a vaccine, a combined vaccine that was given to children of the age of about 2.5, 3. And, but there was some controversy around it because there was one advocate who said that there was an association with the vaccine and autism. So many people didn't give their children the vaccine. Now, from the media point of view, this was a controversy, and so they wanted to present 2 sides of the argument. But the problem was, the majority of medical practitioners were saying there is no such association, and there was one lone voice saying that there is. But to be balanced in the media, they had to present both. Now, since then, the person who was saying that there was an association with autism, they have been struck off, and their research has been sort of seen as not very accurate. So balance in the media is necessary, but I think sometimes people need more information. As a result of this situation, there has been an outbreak of mumps and rubella in a number of places in the UK where children weren't vaccinated, and so they remained unprotected. So this is something that is affecting our lives today. Climate change, the whole big shebang that is climate change. I recently sat on a panel with the IPCC, the International Panel on Climate Change, as they presented their latest results. And in the report that they issued, they said that 95% of climate change scientists believe that climate change is happening through man-made intervention. So that's 95% of climate change scientists believe that climate change is happening due to what we're doing. Now, when this was reported, I got a telephone call from Radio 4, a fairly prestigious channel of the BBC. And they said, Maggie, can you come into the programme and tell us what 95% really means? Is 95% almost certain? Is there anything that scientists are really certain about? And this brings me on to the scientific method. Because as a scientist, it's very hard to say we're certain about anything. For instance, I was trying to give the example that I believe with almost absolute certainty that the Earth goes around the sun. And I believe that, but I can't say 100%. And I'll tell you why. Because of the way the scientific method works, new evidence could be presented that changes my perspective. Because with the scientific method, someone will ask a question, then they'll do research, then they'll put a theory or a hypothesis forward. Then the hypothesis will be questioned. And then if under analysis or with more data, the hypothesis stands, we take it forward. If not, we review the hypothesis and go again. So if you go back 400 years and you said that the Earth goes around the sun, people would have thought you were mad. No, of course, the sun goes around the Earth. We see it rise in the east and we see it set in the west. The sun goes around the Earth. But then more evidence came along and that debunked that theory and a new theory came up. So I'm pretty convinced that nothing's going to come up to tell me that it's different, but I can't say 100% that the Earth goes around the sun, because following the scientific method, there's always that room for doubt. But that room for doubt doesn't always work well with the media. The two don't lie well. People want certainties, and yet science hasn't always got the ability to give them that. Next, I want to talk about STEM and ethics. I spend a lot of my time going out and seeing kids and trying to encourage them to consider careers in STEM. I target my talks at anyone who will listen, actually. In the early days, I mainly targeted at sort of girls, I mainly targeted at school kids. But now I target it at everybody, because as a society, we need an understanding of STEM. And when I go out, over the last 7 years, I think I've seen about 160,000 school kids across the world. And when I talk to them about STEM, I'm hoping that some of them will become scientists of the future, they'll become engineers, they'll become mathematicians. But for the majority of the audience, they don't want to do that. And I think it would be a very scary world if we had that many scientists. So I'm looking to inspire the others, just to have an awareness of STEM. Because STEM is governing our lives. There are so many new products, new theories coming up, new things that are affecting our lives. If we don't have an awareness of STEM, we are very vulnerable. We vote for the people who make the decisions. If we don't have an understanding of the decisions that are to be made, how can we vote for them? Another thing, when I do speak to people who want to be scientists, I want the future scientists, the future STEM practitioners, to go into all walks of life. I want them as politicians. I want them writing columns in newspapers. I want scientists everywhere and to be part of the general community. Because by then, if we do that, we can shed the understanding of STEM to everybody. We can make good STEM decisions for the future. So I've got a few pictures here. One is nanotechnology. Nanotechnology, to me, is mind-blowing. It's the ability to create structures, systems, functioning systems, but at the molecular scale. Now, this sounds as if it's just jumped out of a science fiction novel. And when people think of this, they think of sort of nanites running around people's bodies, cleaning up cells and getting rid of cholesterol. But at the same time, it can be quite scary when you consider this. Now, in the past, as scientists, I think we've been quite pompous, really. In the past, we have gone to sort of people and said, look, these are the facts, we've got to take them in, we're the scientists, we know. But nowadays, we're trying to do things differently. We're trying to set up a dialogue. With the nanotechnology, because we'd had quite a bit of flack from the GM foods, we set up a dialogue. Rather than just telling people that this is safe and it's okay, we asked people in, we invited them, what are your fears about nanotechnology? What haven't we thought of? We see the technology, but we don't always see some of the ethical implications. So let's have a dialogue and work out how we can take this forward together in a way that is safe for everybody. So as STEM practitioners, I think we need to be active in sharing our knowledge, but sharing our knowledge in an accessible way. So people aren't proud of not understanding STEM. People have access to STEM and have access to the understanding of it. Another area in terms of ethics is stem cell research. Stem cell has the potential to transform our lives. For instance, the heart transplant has transformed many lives. Stem cell research has the opportunity to do that and so much more. With stem cells, we can actually take stem cells and make different types of tissue. So you can take your own stem cells, make tissues for your own body so you don't suffer from rejection and things like that. But is this ethical? These are the questions we need to be answering. As scientists, sometimes we get too caught up in what we're doing. We need to see the bigger picture, and the people to give us the bigger picture are the general public. So we need to work together to get a better understanding. But when I talk about this, it all seems from a very Western point of view. And I'll give you an example. A few years ago, I had the luxury of going to Tanzania, and I can't wait till I can get back to Zanzibar Island. But while I was there, I was called Black Mzungu, no Swahili. And unfortunately, it summed me up beautifully, because it means Black European that doesn't speak Swahili. And so my perspective is very much a Eurocentric perspective. And I think many people might argue that STEM for everybody, there are many people in the developing world that don't need STEM, but I'd argue that yes, they do. STEM gives us the ability to transform lives. If you have an understanding of crop rotation, then you can increase your yield. Rather than just telling people to rotate their crops, if they understand the principle behind it, it means that they understand the thought behind it. They can do more to it. If people understand the transmission of AIDS, they can understand how to protect themselves and how to protect their families. If you understand how germs are transmitted from one person to another from infected water, you can perhaps do things to protect you and your family. So STEM isn't just for sort of a few people in ivory towers. STEM is affecting all of our lives. And by having an understanding of STEM, we can actually come up with practical solutions. And practical solutions, I think, in the developing world are what it's really about. Simple solutions for simple problems. I think we have a whole dialogue on this coming up tomorrow. But if you give people the ability to have some STEM understanding, some engineering understanding, local people to solve local problems, if they have those understandings, they know their problems, you might be able to better equip them to solve those problems in the future. So I've spoken about how the ethics of STEM is important. I've spoken about how STEM is part of our lives and we need STEM glasses to see through some of the smoke screens that are put out there. But I think one of the most powerful things about STEM is that sense of wonder. As a 3-year-old child, I was born in 1968, and as a 3-year-old child, I was just blown away by things like the moon landings, hearing that someone had landed on the moon. I look at the images taken by the Hubble Space Telescope, and it blows my mind. STEM gives us the same effect that art, that literature, that music, it gives us the same effect as that if we sell it properly. Here in Qatar, we are surrounded by magnificent architecture. When my daughter and I were coming from the airport, she's only 3, and we were looking at the window. Look at that building. That one looks as if it's got a pineapple on top. We were enjoying the spectacle that is out there. There are fantastic buildings out here. Yesterday, we had a meal at the Museum of Islamic Art, and I must admit, I stood there transfixed as the sort of sun was setting, and this amazing white building stood there. And it made my heart glad to see it. This is engineering technology at its best. How can we say that this isn't part of our culture? There are a number of buildings here that we can enjoy. And just driving around this area, we can see the beautiful effects. But there are also technological advances. I mentioned the human genome earlier, but there is a new branch of biology which recently came up, which is called synthetic biology. When I heard about this, I was mind-boggled. Again, it seemed to jump out of the pages of science fiction. Synthetic biology is the ability to take synthetic DNA, put it into a living cell, and then you can create products, proteins, insulin. You can create products from synthetic DNA. This feels almost like tinkering with life. But how do we handle this? Is it ethical? What do we use it for? These questions need to be answered. Science and STEM gives us wonders, but they need to be controlled. In my area, I am a space scientist, but I worked as an astronomer in some fantastic telescopes in Chile. I've worked in the Gemini telescope, which was a fantastic place, and also the VLT, which is the very large telescope in the Atacama Desert. And astronomers have slightly boring names for things, but now we're working on a telescope called the ELT, which stands for the Extremely Large Telescope. And in the next 20, 30 years, we will have the OWL, which is the Overwhelmingly Large Telescope. With these telescopes, we're looking deeper and deeper into the universe. Can I cue the video, please? We're looking deeper and deeper into the universe. We're being able to see things that we didn't understand before. There was a recent survey conducted in the UK, and the question we asked was, what is the scientific question you would most like to be answered? And when people came back, the question that most people wanted answered was, is there life in the universe? This is a philosophical question. It's a cultural question. One of the things I'm fascinated by is archaeoastronomy, looking at the astronomy of cultures across the world, and everybody has looked up at the night sky and wondered. This is part of our culture. And with videos like this, I take children on tours of the universe. You can see down there, our solar system is receding, and now we're looking at the sun from a distance. But what many people don't realize is each one of the stars we see in the night sky is a sun like our sun. And if it's a sun like our sun, it means that they have planets going around them. And now, for the last 10, 15 years, for the first time, we've actually been able to detect those planets. detect planets going around other stars. And this is a video showing each one of those blue rings represents a planet, an exoplanet, going around another star. So we're getting closer and closer to answering that question. And as we zoom out, we're going to visit a star with a number of exoplanets. So this is our galaxy, the Milky Way. The Milky Way contains 200 billion stars in it. It boggles my mind to think of it. And this is one star with 4 exoplanets going around them. Now, we've just about been able to detect these exoplanets, and we've detected about 700, 800 exoplanets. But what we're doing now is we're actually detecting the atmospheres of these exoplanets and looking for the fingerprints of life. And with the telescopes like the ELT and the OWL, in the future, we might actually be able to find signs of life on other planets. A fundamental question asked by cultures across the world, and we're getting closer to answering it. So, a few years ago, I had the pleasure of going to South Africa, and I visited SALT, the South African Large Telescope. And I must admit, when I was there, I was blown away. This is a 10-meter telescope on African soil. I was so proud. But at the same time, I was a bit reticent because I was visiting this telescope and I was thinking that this is South Africa. South Africa has the legacy of apartheid. It has an AIDS epidemic. Are they happy with money being spent on a telescope like this? So I spoke to some of the local people and said, yeah, how do you feel? Are you happy with this telescope? And they answered me, Maggie, you don't understand. Yes, we have problems here in South Africa, but at the same time, we're reaching for the stars. And I think that's what STEM can give us. It can allow our minds to roam. It can inspire us to do more. Yes, we have our local problems, but we can look up at the same time. So for my final slide, I'd like to actually talk about a video about a quote from Richard Feynman. Feynman met up with a friend who was an artist. And his friend, he was speaking to his friend, and his artist friend said, look, Feynman, you scientists, you've got it all wrong. I see a flower, and I can appreciate its beauty. You see a flower, and you dissect it and take it apart. You have no appreciation. And Feynman said, no, my friend, you've got it wrong. I see a flower, and I see its beauty just as you do. But on top of that, I see an inner beauty. Because I see the colour of the flower, and I know that that colour has evolved to attract certain insects. If you look at that flower in ultraviolet light, suddenly you see tracks guiding the insects down to the nectar so the flower can be pollinated. And then if you look at the flower under a microscope, suddenly you see the cells, and you can see them doing virtual magic. They're taking carbon dioxide, they're taking sunlight energy, and they're creating sugars. And that is what fuels the world today. It fuels what we eat, it fuels the oil and gas that we use. It's fueling our world. So you see the beauty of a flower, but I see the beauty of a flower and so much more. And that's what STEM gives us. STEM is changing our world. It seems foolish not to have an understanding of it. STEM is vital to our economies. We need STEM practitioners so we can fuel those economies in the future. As a STEM practitioner, I feel that in the past we've been very poor about sharing the wonders of STEM. So as STEM practitioners, we need to get out there and make STEM accessible for everybody. On top of that, STEM isn't just about doing something in a lab. It's not about people in ivory towers. STEM is engineering. It's good practical solutions. You have a problem, you find a solution. Giving people STEM skills helps them do that. I think we all need an understanding of STEM so we can guide our future, the future of our technology. Without that, I think we have scary times ahead. And finally, I think STEM deserves to be celebrated. It's just as good as art, literature, and music. And I think it can give us all a sense of wonder. Fundamentally, I think STEM helps us reach for the stars. And I think that's something that we all deserve. Thank you.